I'm Dr. M. Fatima, taking operational amplifier. In this, I will take inverting amplifier. First of all, operational amplifier. The operational amplifier can perform number of operations and can do the amplification also. That's why the name is operational amplifier. This is the diagram of the operational amplifier. The positive sign is showing the non-inverting input terminal. Negative sign is showing the inverting input terminal, and from here output is taking. The resistance is connected at the inverting terminal, and the feedback resistance is also connected at the negative terminal. The input is given to the operation amplifier. The operation amplifier will amplify the input signal. As the frequency changes at input, the output will also change its frequency. The frequency of input signal and output signal will be the same. The operational amplifier mainly do the amplification and different operations. Now I'm taking inverting amplifier. An inverting amplifier is a type of operational amplifier circuit which produces an output out of phase with respect to its input by 180 degree. This means that if the input signal is positive, then the output signal will be negative, and vice versa also. So you can see here, this is the diagram of operational amplifier. On the negative terminal, input is giving, the output is amplified with a phase difference of 180 degree. The output is inverted. That's why the name is inverting amplifier. This is the circuit diagram of the inverting amplifier. Here the gain with feedback will be calculated in this lecture. So the gain with feedback is, you can see here, the output voltage divided by input voltage. In this circuit diagram of inverting amplifier, V0 is output, Vi is input, Ii is input current, Ri is input resistance, RF is the feedback resistance connected between input and output network, V1 is the voltage present at the negative terminal, V2 is the voltage present at the positive terminal. This II current is divided into two paths, I1 and IF. So II is equal to I1 plus IF. This I1 is flowing inside of the op-amp, but here the input resistance of op-amp is very high. So this current, I1 current, is a negligible current. The most of the current will be flowing through the feedback path, that is IF. So II is approximately equal to IF, where I1 is approximately equal to 0. So I can put II equal to IF. Now calculate the voltage drop across this resistance and across this resistance. The voltage drop across this resistance is II, Ri. This is equal to Vy minus V1, where this Vi is present at this terminal of the resistance and V1 is present at this terminal of the resistance. Now the voltage drop across feedback resistance, it is equal to IF, RF. It is equal to V1 minus V0. Here it, on this terminal of RF, V1 is present, and on this terminal of RF, the V0 is present. So write them mathematically. Vi minus V1 equal to II Ri, and V1 minus V0 equal to IF RF. Here it is written. Now replace this II by IF. So here the equation is written. This II is replaced by IF. This equation remains the same. Now see, as we know that in the inverting amplifier, the negative terminal is acting as at virtual ground. So V1 is equal to 0 since V2 is equal to 0. So put V1 equal to 0 here in these equations. So now this is the equation. Now you can see Vi is equal to IF Ri and minus V0 equal to IF RF. Now do the division of V0 by Vi. So minus V0 upon Vi is equal to IF RF upon IF Ri. So this is equal to minus RF upon Ri since IF are cut down. So this is the voltage gain of inverting amplifier, which is equal to minus RF upon R1. That is voltage gain of inverting amplifier depends on the value of feedback resistance and input resistance. Here this is showing the input and output waveform of the inverting amplifier, as we have already seen. Here the input signal without with 0 degree phase. Initial phase is 0 degree, and voltage here it is considered, let it be 2 volt. Now the inverting amplifier amplifies the signal and inverted the phase, or give the phase shift of 180 degree. So you can see here this the input signal is amplified with phase inversion of 180 degree. So inverting amplifier, in a nutshell, the inverting amplifier amplifies the input signal with a phase shift of 180 degree. Thank you.